Hello everyone. So let me continue the chemical kinetics. Right. Listen. See, today's topic is factors influencing rate of reaction. Okay. So today's topic is factors influencing rate of reaction. So what factors generally influences the rate of reaction? Factors influencing rate of reaction. Now, the first and important factor is the nature of reactants. See, rate of reaction depends on what? Nature of reactants. Kaise? It's very simple. Ionic reactions are instantaneous, means very fast. They may complete in fraction of seconds, whereas covalent reactions require some time to complete. So, what is the difference? Just the difference is mechanism. In case of ionic reactions, the mechanism involved is just exchange of ions. Ions are exchanged with each other. So, the quite simple mechanism and it may take place in very less time. Whereas in covalent reactions, bond breaking and bond making processes are involved. These processes require some time to complete. That's why covalent reactions are slow and ionic reactions are fast. So, this is the first factor, nature of reactants. Understand? What do we have to write here? Ionic reactions are quite faster. You can call them as instantaneous reactions. Okay, very fast reactions. Since the mechanism involved is exchange of ions. Since the mechanism involved is exchange of ions. Exchange of ions. For example, AgNO3 aqueous silver nitrate reacts with NaCl aqueous gives rise to AgCl aqueous precipitate plus NaNO3 aqueous. So this is the best reaction here. Silver and sodium exchanges with each other so that it gives precipitate. See, this reaction completed in fraction of seconds. ऐसा डाल रहा है सिल्वर नाइट्रेट in NaCl, तुरंत precipitate होना शुरू हो जाएगा. So that's why it's a spontaneous, a very fast reaction. That's just because of the mechanism. Okay. Next, covalent reactions. Covalent reactions are slow due to bond rearrangements. Covalent reactions are slow due to bond rearrangements. Sir, what are bond rearrangements? अरे पुराना bond को तोड़ना है, नया bond को जोड़ना पड़ेगा. So the old bonds get disrupted and the new bonds are formed. That's why it may require some time-taking reactions. So covalent reactions are slow due to bond rearrangements. You can go through some reactions like H2 plus half O2 gives rise to H2. See, this is a slow reaction. Without catalyst, it may take 1 year to complete an extent of 1%. अगर कैटलिस्ट नहीं है तो ये रिएक्शन 1% होने के लिए 1 साल लगेगा, तो 100% के लिए 100 years लगेगा. So without catalyst, हाँ catalyst होगा तो it speeds up the reaction. Okay. So why? Because here bond breaking and bond making processes make the reaction very slow. Is that clear? So like that, ionic reactions are quite fast, whereas covalent reactions are somehow slow. Okay. And one more important point here is if you see the covalent reactions, if you want to compare two covalent reactions where the number of bond rearrangements are less, that occurs at faster rate. Understand? So covalent reactions with few bond rearrangements are occurs at faster rate when compared to more number of bond rearrangements. Okay, so write that point. Covalent reactions with few bond rearrangements. Covalent reactions with a few bond rearrangements are occurs at faster rate when compared to covalent reaction with more number of bond rearrangements. More number of bond rearrangements. Right? So, covalent reactions with few bond rearrangements are occurs at faster rate when compared to covalent reactions with more number of bond rearrangements. Okay? For example, if you take 2NO gas plus O2 gas gives rise to 2NO2 gas. And another example, methane combustion, CH4 plus 2O2 gives rise to CO2 plus H2O. Okay. So these are the two equations. Among these two, which one occurs at faster rate? Of course, oxidation of nitric oxide, because where the rearrangements are less when compared to the second one. Second one may maximum bond rearrangements are present. So therefore, if it is 1, it is 2. Equation 1 occurs at faster rate due to few bond rearrangements. मतलब less number of bond rearrangements है. That's why equation 1 occurs at faster rate. Is that clear? So this is about the first factor, that is nature of reactants. Okay. Now coming to the second factor, that is concentration. Okay, allow me to go to the second factor, concentration of reactants. Okay, the second and important factor is concentration of reactants. Okay, listen carefully. According to law of mass action, according to law of mass action. See, already studied in chemical equilibrium also. Law of mass action. See, it was introduced by Gullberg and Weiss. Okay. See, law of mass action. What is the use of this law of mass action? It indicates or it describes the relation between rate of reaction and concentration term. So it indicates or it explains the relation between rate of reaction and concentration terms. Okay, listen. According to this law of mass action, rate of reaction is directly proportional to product of molar concentration of reactants. Okay, this is the statement. As per law of mass action, rate of a chemical reaction is directly proportional to the product of molar concentrations of reactants. Okay. Now, so according to this, we can understand rate always depends on molar concentration of reactant. But कुछ exceptions are there. What are they? Except zeroth order and negative order reactions. Except zeroth order and negative order reactions. In remaining cases or in remaining reactions, the rate of reaction is directly proportional to the rate of reaction is directly proportional to concentration of reactant. Right? Concentration of reactants. Okay. Have understand? If you want an example, for suppose if you take it like this, H2O2 and decomposition gives H2O plus half O2. तो यहाँ पे क्या लिखते हैं? Rate is proportional to concentration of H2O2. Then rate is equal to some constant K into concentration of H2O2. Okay? Have understand this? Okay, like that you can understand the effect of concentration on rate of reaction. Okay? Initially reactant concentration maximum रहता है, so initial rate is maximum. धीरे धीरे टाइम प्रोसीड्स होने तक मतलब टाइम प्रोसीड्स होते जा रहा है तो concentration धीरे धीरे कम होते जाएगा ना, so rate with respect to reactant decreases gradually. Clear? Is it clear, laughing? Right, correct. Next. And one more important point you have to understand here. See, let me go through one more important point. Sir, what is it? See, let me go through a note. Okay. So note means it's an important point. That's it. Okay. Now, it is not necessary that all reactant terms can decide the rate. It is not necessary that all reactant terms or all concentration terms of reactant that can decide the what you call rate of a reaction. Kyunki if any reactant is taken in excess, rate is independent of that reactant. So that is the point I want to write here. If the concentration of one of the reactant, if the concentration of one of the reactant is taken in excess, right? If the concentration of one of the reactant is taken in excess, then rate is independent. That rate is independent of concentration of that reactant. मतलब जो जिसका concentration ज़्यादा रहे उसके ऊपर rate कभी depend नहीं होता है, वही लिखा हुआ है. If the concentration of one of the reactant is taken in excess, then rate is independent of concentration of that reactant. Is that clear? Have understand? So this is the second factor, that is concentration. Now coming to the third and important factor. Right. So third factor is the temperature. See, if you see the temperature effect, remember all of you, as the temperature increases, in general, मतलब for most of the reactions, right? As the temperature increases, in general, rate of most of the reactions, few exceptions हो सकता है, right? But most of the reactions, मतलब 99.9% will follow this. So as the temperature increases, in general, rate of most of the reactions increases. Rate of the most of the reactions increases since number of active collisions increases. Number of active collisions increases. Sir, what is this active collisions? So don't worry, it will be explained again in collision theory. It will be described at the end of this chapter, where you can understand what are collisions, what are active collisions, why necessary of collision, what necessity of the collisions for product formation. Okay, as temperature increases, in general, rate of most of the reactions increases since number of active origins increases. Okay, next, one more important point. For every 10 degrees centigrade rise, for every 10 degrees centigrade rise in temperature, for every 10 degrees centigrade rise in temperature, makes the rate either twice or thrice, either twice or thrice to the initial rate, to the initial rate. Understand? For every 10 degrees centigrade rise in temperature makes the rate either twice or thrice. Okay? So this is about the effect of temperature on what you call the rate of reaction. So the next factor is catalyst. So listen carefully. See, catalyst. How catalyst influences rate of reaction? If you consider the catalyst. Okay. So first you should understand how many types of catalysts are there. Two types of catalyst, positive and negative catalyst. So positive catalyst increases the rate by decreasing activation energy. Negative catalyst decreases the rate by increasing activation energy. Sir, what is this activation energy? Don't worry, it will be explained in this chapter only. Maybe by tomorrow or day after tomorrow class you will get it. Okay. But right now I want to continue the remaining aspects. So I am going through explanation of activation energy in another class, right? So right now just to go through these factors. So catalyst. So it's my first point here. A positive catalyst increases the rate of reaction by decreasing activation energy. Okay. Similarly, a negative catalyst decreases the rate of reaction. Negative catalyst decreases the rate of reaction by increasing activation energy. Understand? A negative catalyst decreases rate of reaction by increasing activation energy, and a positive catalyst increases rate of reaction by decreasing activation energy. So that's it. It's about effect of catalyst. Now, listen. Put a note and go through a point also. Now in some photochemical reactions or photolysis reactions, okay, in some photochemical reactions or photolysis reactions, rate depends on intensity of the incident light, okay, or incident radiation. So you should understand this one also. कभी-कभी rate किसके ऊपर depend होता है? Intensity of the incident radiation. अगर if it is photolysis or photochemical reaction. So that's it. So these are some factors which influences rate of a chemical reaction. Okay. Now let me continue order of the reaction. So I love you. It's an important point. So please listen carefully. Coming to order of the reaction, how we can describe order and etc. Right, listen. order of the reaction. Okay, now listen. See how you can describe order of the reaction and remaining aspects. Okay, listen carefully. See, before going to describe this order, first you have to understand rate expression or rate law. Okay, yes, I'll explain the order. Before that, I'll go through rate law. So, rate law or rate expression. Sir, what is this rate law or rate expression? ये क्या होता है sir? It's very simple. The equation which describes the dependence of rate of reaction on concentration term. Okay. The equation which describes the dependence of rate of reaction on concentration terms is called as a rate law or rate expression. Okay. For example, if I give n moles of A gives rise to products. अब ऐसा एक reaction निकालो, n moles of A gives rise to products. So then rate is equal to rate proportional to concentration of A power n. Then rate is equal to K into concentration of A power n, where n is considered to be order of reaction. Okay, where n is considered to be order of reaction. एक कब होगा? If it is an elementary reaction, then only it's possible. Okay. एलिमेंट्री मतलब वो इक्वेशन एक ही इक्वेशन है, उसके अंदर कुछ स्टेप्स नहीं है, ये एक ही स्टेप में कंप्लीट हो जाएगा. Then we call it as elementary reactions. In such reactions only we are describing like this. Okay, where n is order of the reaction. Is that clear? So this अभी जो यहाँ पे लिखा हूँ ना मैं, rate is equal to K into A power n. So this is called rate law or rate expression. इसको हम कहते हैं rate law or rate expression, right? So now you can understand what about rate law. Okay. Now let me go through this order of the reaction. Okay, order. Please listen. Now listen carefully. Order of the reaction. See, order is defined like this. The sum of the powers of concentration terms. The sum of the power of concentration terms of rate law or rate expression. Of rate law or rate expression is called as a order of the reaction. Understand? The sum of the power of concentration terms of rate law or rate expression is called order of the reaction. Okay. For example, A plus B gives rise to products. Okay, that too it is an elementary reaction. मतलब it happens only in one step. Then rate is proportional to concentration of A into concentration of B. Then rate is equal to K into concentration of A into concentration of B. So powers क्या है यहाँ पे? कुछ नहीं है, तो मतलब power 1 तो यहाँ पे क्या लिख सकता है? Order with respect to A is 1 and order with respect to B is also taken as 1. So therefore overall order of the reaction is equal to 1 plus 1, that equal to 2. Okay, so like that, the sum of the powers of concentration terms of rate expression or rate law is considered to be order of reaction, and please follow these expressions. Okay, right. Next, see, order of reaction is not derived theoretically like this. It is an experimental quantity. So if you go through the characteristics of order, let me go through one by one. Okay. See, first point, order of a chemical reaction. Order of a chemical reaction is an experimental quantity. Is an experimental quantity. Okay. Next, the second point. Order of a reaction. Order of a reaction may equal to positive or negative values, positive comma negative, or may equal to 0 also. Order of a reaction may equal to positive, negative, or 0. Even fractional values. Or even fractional values. Okay. See, order may equal to positive integers or negative values or 0, even sometimes fractional values. Right? Next, order of a simple reaction. Order of a simple reaction may not exceed 3. मतलब in some simple reactions, if you consider, order may not exceed 3. So these are the points you have to remember. Order of a chemical reaction is an experimental quantity. Order of a reaction may equal to positive, negative, or 0, even fractional values. Order of a simple reaction may not exceed 3. Okay, so please note it down. And okay, now how you can derive order of a reaction? Okay, so let me go through that derivation, calculation and the derivation part. और rate law कैसे express कर सकता है ये सब बताएंगे, ठीक है? Now first continuation and first point is order of elementary reactions. Order of elementary reactions. So listen carefully. See, first elementary reaction means what? Remember, the reaction which is completed in a single step. The reaction which is completed in a single step is called as elementary reaction. Is called as elementary reaction, and there is no detectable reaction intermediate, and there is no detectable reaction intermediate. Understand? So the reaction which is completed in a single step is called elementary reaction, and there is no detectable reaction intermediate. Okay. For example, NO2 gas, nitric oxide, nitric oxide. Nitric oxide when reacts with ozone, it gives rise to nitrogen dioxide plus oxygen. See, this is the best example for elementary reaction. This is the best example for elementary reaction. Therefore, यहाँ पे rate law कैसे express करेंगे? So rate is proportional to concentration of NO into concentration of O3. Then rate जगह R लिखते हैं is equal to some constant K into concentration of NO into concentration of O3. So this is called rate expression or rate law, and the proportionality constant here is called rate constant. It will be described in detail in tomorrow's class, right? So understand this. So like that you can express the rate law or rate equation. So now individual orders देख लेंगे तो order with respect to NO nitric oxide is 1. Order with respect to order with respect to ozone is also 1. So overall order 1 plus 1 2. Okay. If you want a fractional individual orders you can say. Okay. मतलब one of the component have order 1, इसका भी order 1. So overall order is 1 plus 1 2 होगा. Okay. Next. Now coming to order of composite reactions. Right. Listen. Order of composite reactions. Okay. Listen carefully. If a chemical reaction takes place in more than one step, if a chemical reaction takes place in more than one step, it is called as a composite reaction. It is called as composite reaction. Okay. Therefore, the rate law of composite reaction. Therefore, the rate law of composite reaction is derived from slow step or rate determining step. Slow step is also called rate determining step of the composite reaction. Understand enough? Okay. See, first order of composite reactions we are describing. See, first of all, what is composite reaction? ये क्या होता है? Composite reaction means if a chemical reaction takes place in more than one step and there will be some detectable reaction intermediates, one intermediate or two intermediate, it depends on the number of steps there. So, अगर कुछ detectable intermediate steps रहेगा तो then it is called as a composite reaction. Okay. In such cases, how you can describe the rate law or rate expression? So that is from slowest step. That is what you written in the second part. The rate law of composite reaction is derived from slow step or rate determining step of that composite reaction. Slow step or rate determining step. Okay, for example, if you go through an example here, composite reaction के लिए एक example आप ले सकता है. Reaction between nitrogen dioxide and carbon monoxide. See, reaction between NO2 and C. So this is the best example. Okay. Generally given as NO2 gas plus CO gas gives rise to NO gas plus CO2 gas. One step in the reaction happens like this. Overall reaction is given like this. NO2 plus CO gives rise to NO plus CO2. Nitrogen dioxide plus carbon monoxide gives rise to nitrogen monoxide plus carbon dioxide. Okay. Now, see the mechanism of this process. If you consider the mechanism, the steps of this reaction. The first step, NO2 plus NO2, right, gives rise to NO3 plus NO3 plus NO. Now in step 2, NO3 gas plus CO gas gives rise to NO2 gas plus CO2 gas. Okay, so this is the mechanism of this. Okay, the mechanism is written like this. First, NO2 plus NO2 gives rise to NO3 plus NO. NO3 plus NO. Nitric oxide NO. NO3 plus NO. Okay. Now, second step, NO3 plus again CO gives rise to NO2 plus CO2. In those two steps, first step is, we observe that first step is somehow slow and second step is faster step. Therefore, what is rate determining step? The slow step of the process, the slow step of the mechanism is considered to be rate determining step. Therefore, a rate law of that reaction is equal to, therefore rate law R is equal to K into concentration of NO2 into concentration of NO2. So R is equal to K into concentration of NO2 power 2. Clear? So this is the rate law or rate expression for a composite reaction. ओके, इससे आपको ऑर्डर पता चल जाएगा. अभी ऑर्डर यहाँ पे 2 आ रहा है क्योंकि दिस इज द रेट लॉ. यहाँ से तो पता चल जाएगा, बट ये कैसे आएगा? मतलब बाय मींस ऑफ सम एक्सपेरिमेंट वी कैन डिराइव दिस एक्सप्रेशन फर्स्ट. ओके, उसके ऊपर हम कुछ प्रॉब्लम्स कर सकते हैं, उसके ऊपर वो कल बताएंगे वो प्रॉब्लम्स. सो ऑर्डर कैसे हम एक्सट्रैक्ट कर सकता है फ्रॉम द एक्सपेरिमेंटल डेटा, दैट्स वी स्टडीड बाय टुमारो. ओके, so I'll go through one more example for this rate law of a composite reaction. Okay, so let me go through one more example. Agar if it has equilibrium process, like first I am going through an equation, right? 2NO gas plus F2 gas gives rise to 2NOF gas bubble. So this is the equation. I think it is visible, I think, right? Okay, 2NO plus F2 gives rise to 2NOF. Okay, it has mechanism that NO gas plus F2 gives rise to NOF2 gas. Okay, so first NO plus F2 gives rise to NOF2. That too, it is an equilibrium process, forward backward. अरे reversible arrow है ना यहाँ पे, so it is an equilibrium or reversible reaction. Next, second step, again this one, NOF2 again reacts with what? NO gives rise to 2NOF. So यहाँ पे the mechanism of this particular process is given like this, and the second step is taken as the slow step. Not myself. The second step is given as a slow step according to its mechanism. The reaction between nitric oxide and fluorine is given like this. It is in two steps. First step is reversible. Okay, second step is a slow step of the rate or rate determining step. Slow step of the process or rate determining step. So first, what you can able to write? So first you can write that a rate law. Okay, rate is proportional to concentration of NOF2 into concentration of NO. So R is equal to K into concentration of NOF2 into concentration of NO. Make it as equation 1. तो फर्स्ट रेट लॉ यही है ना. द फर्स्ट रेट लॉ इज लाइक दिस, बट इट इज नॉट सैटिस्फाइंग द ऑर्डर. क्यों? ये NOF2 रिएक्टेंट में कहीं नहीं है. अरे रिएक्टेंट NO है, F2 है. सो रेट लॉ शुड बी इन टर्म्स ऑफ रिएक्टेंट्स. रेट लॉ शुड बी इन टर्म्स ऑफ रिएक्टेंट, नॉट इन टर्म्स ऑफ रिएक्शन इंटरमीडिएट. So this is one of the possibility, but it is not 100% correct. अरे this rate lies one of the possibility, but it is not 100% correct because यहाँ पे आप intermediate use कर रहे हैं. So reactant terms चाहिए हमको. So इसको फिर आगे बढ़ते हैं. कैसे? आपको इक्विलिब्रियम टेस्ट इक्विलिब्रियम स्टेप देखो. इक्विलिब्रियम स्टेप. तो Kc equilibrium constant is equal to concentration of MoF2 by concentration of MO into concentration of F2. ओके, इससे हम concentration of MoF2 कैलकुलेट करेंगे. मतलब concentration of MoF2 is equal to Kc into concentration of MO into concentration of F2. Make it as equation 2. Okay, just make it as equation 2. Now substitute equation 2. Substitute equation 2 in equation 1. In equation 1. Okay. Then R is equal to K into MoF2 जगह क्या ले सकता है? Kc into concentration of MO into concentration of F2. Again, one more concentration of MO is there. So therefore, R is equal to K into Kc. K into Kc, I am taking it as K dash NO. So concentration of NO power 2 into concentration of F2. अब अभी देखो order with respect to NO is 2. Again order with respect to F2 is 1. So like that you can derive the order of reactions. Okay. So overall order of the process is 1 plus 2 that equal to 3. Right. So that's it now. So this is about order. Okay. So we have to do some questions based on this order. Okay, I will do those questions in next class. Okay. So my sincere request to all of you, please like, share, subscribe, and you can give some valuable comments also regarding this information, whether it is useful or not. Okay, so all of you, please do that. Okay, so again I'll meet you continuation of this chapter, along with the continuation of this chapter. Until then, bye bye.